navire de recherche du gouvernement du Nunavut, lancé d'ailleurs tout récemment en juillet 2011. Alors, je suis plus précisément dans un espace laboratoire de ce nouveau navire de recherche avec le docteur Nigel Hussey de l'Université de Windsor. Et je vais lui demander qu'est-ce qu'il fait exactement dans la baie de Cumberland en termes de recherche. Alors, docteur Hussey, j'aimerais que vous nous expliquiez quel est l'objectif de votre projet de recherche. So, Dr. Hussey, I would like you to hear about the objective of your research here in the Cumberland Sound.
The main focus of why we're working in Cumberland Sound is the turbot fishery, or actually the species is Greenland halibut, but it's referred to here as turbot. Traditionally in the north of Cumberland Sound, which if you look on the map is this area here, this is Pangaton, there is a fishery through the ice in the winter, which is where they cut the holes into the ice and then they fish with long lines through this. Over the past 2 years there's a developing fishery, a commercial fishery, which is now operating in the southern area of Cumberland Sound. And this fishery is also long line because they can't trawl. Trawling is banned by the Hunters and Trappers Association in all of Cumberland Sound. Now, when you start to have two fisheries operating, you obviously need to have a better understanding of your stocks, or i.e. the population of the fish in your system, so then you can provide the guidelines for how many fish can be taken each year as a quota. So our overall objective is to try and understand the turbot movements. And the first question is are the turbot populations, is it one big turbot population that both the Inuit will be taking from the ice and the commercial fishery will be taking in the summertime, or is it two separate distinct stocks of turbot which would obviously have different management quotas? And to do this we are using various equipment to look at the movements, various different tags that we're using.
Et vous travaillez également sur l'interaction entre les requins, les populations de requins et les populations de turbot. So you're working also on the interactions between sharks populations and turbots populations.
Yes, with the trial fishery, the commercial fishery in the summer, which would be very beneficial to the Inuit communities if this fishery could be developed. The one big problem that we've got in the initial trials is the bycatch of Greenland sharks in this fishery, and the bycatch is huge. It's on a massive scale, which is not surprising considering that this area is a relatively pristine system that hasn't had a level of industrial fishing previously. Now, with the current bycatch, the fishery will not be allowed to continue. So what we're trying to do is look at the interactions of the Greenland shark, i.e. how long do they stay in the Cumberland Sound area, how much of their time is actually spent in the region, these deep water pockets, which is where they principally find the turbot in the summertime. So we can get a handle of the interaction times between the two species, and then we can start to think of ways in which we can try and reduce this bycatch within the fishery.
Is this brand new research on those interactions, or?
Yes, it's the first time that this research has been done. It's also the first time that the equipment that we're using has been deployed in these conditions. Most of the time the monitors and the tags that we are using are deployed in shallow water systems, usually 100 or less than 100 meters depth. At the moment we're putting these monitors in at 1,000 meters up to 1,400 meters. So it's the first time, it's completely unique what we're doing. But obviously it has to be, because we're studying a very difficult to study species. The Greenland halibut are very deep water animals, benthic species that live down in these very deep water pockets, and the Greenland shark is also a very deep water animal.
Alors, comment étudiez-vous les interactions entre les populations de requins et les populations de turbots du Groenland? So how do you study the interaction between the sharks populations and the Greenland turbots populations?
Okay, the main way, my main focus within this project is on actual movements of these animals. And to do that we use two different techniques. The first is we have what we call acoustic receivers. They fix down onto an anchor, onto the base of the ocean, and then they come up from this to a float. And also on the line we have this piece of equipment, which is called an acoustic release. And basically this monitor here listens. It listens continually, 24 hours a day, all year. So, I've lost it. Can we go back and I'll start?
Just keep going.
Continue.
Just keep going.
Yeah, that's perfect.
Okay.
Not a problem.
So this monitor will listen continually for fish that we put tags in. And for the turbots, this is the type of tag that we put in the animal. We do surgery, we cut a small incision into the body cavity, we push the tag inside the animal, and then we suture it up exactly as if you went to the hospital and had surgery done. And then when that fish swims within range of this receiver records a specific identity code, so we know which fish it was, and it records the time and the date of that animal. And these monitors have a kilometer range in a bubble around them, so they can listen quite a long distance. We then leave, we have all these monitors positioned in the fishing grounds, many of these, both in the summer and in the winter fishing grounds. And next year we come back up and we put this device into the water, this hydrophone, this acoustic hydrophone. We drop this into the water, we send a command from this box, and this releases this from the anchor. So this and this then float up to the surface. We recover this, we plug it into the computer, and this will tell us all of the fish that have been detected within this monitor range. So then we can start to address the questions. If we've got these ones, these monitors and fish tagged in the summer fishing ground, and we've got these monitors in the winter fishing ground, what we would expect to see if it's only one population is all of these fish in the summer will stay there for 3 or 4 months, and we keep hitting detections on these monitors, and then suddenly we'll get no data on these monitors, and then we'll start to detect all the fish on these monitors that are positioned in the winter fishery grounds.
This is the assumption that this is the same stock.
Same stock.
They are moving.
If it isn't the same stock, what we'll be doing is in April we come back up here and we go out with the Inuit and we fish through the ice, and we're going to tag turbots through the ice at that time of year. So then we know that those fish went in the northern area, and so we would expect to be hearing those on that northern fishing ground. If they stay there all year, then we'll have detections all year. If they only stay for 2 or 3 months, we'll hear them, no detections, the fish move, and then we'll hear the detections in the summer fishing ground.
And what about the sharks?
Okay, the sharks, we do the same. The sharks, we have a slightly larger acoustic tag than this one. We catch them on specially set long lines. We bring the sharks up next to the boat, we put a rope around the tail, a rope around the pectoral fins at the front of the shark. We hold it next to the boat, turn the shark upside down so it goes to sleep, what we call tonic immobility, and then we do a small incision into the body cavity. We push the tag inside, we suture up, and then we let the shark go again. And exactly the same principle. The monitors will detect the tagged animals. The second method that we use both for the sharks and for the turbot are what we call pop-up archival satellite tags. These go externally, so they have a wire to a dart. We push the dart into the muscle tissue either of the shark or the turbot, and these tags will record the depth and temperature of the shark or the fish every minute and a half, every 2 minutes, continually. We then program these tags to pop off. So this can depend on what we choose. We generally choose from 1 month up to a year. So after 1 month, for example, if we program for 1 month, the tag will detach from the fish after 1 month, floats up to the surface of the ocean, and then it will start to transmit its data through this antennae up to above satellites. We then contact through satellite and we can download all of the data, so it gives us very accurate, vertical movements of the depth and temperature preferences of these fish throughout the year period.
So this is the first year. So far there's no results, of course, at this point. So what are your expectations? I mean, in terms of stocks, interactions, and ultimately in terms of fisheries.
Okay, in terms
If you
of
would have to predict something.
if to predict, I think that what we will find is, I think that the turbot actually there'll be what we call substructure within the population. And what we'll find is that some of the turbot that we tag in the summer fishing grounds will stay there all year round, but some will move up into the winter fishing grounds. And we know that if we go today, for example, in the summer, into the winter fishing area and try and catch turbot, it's very difficult to catch them. So in a sense, we can guess that there is one overall population, and that the turbot do move from the summer fishing grounds to the winter fishing grounds. But we also have a good feeling that some of the turbot in the summer fishing grounds stay there as well. Now, why that is, we don't yet know. All of the fish that we tag, we take a fin clip sample, so we will do genetics to see if there's some sort of genetic substructure within the turbot population. In terms of the sharks, I think what we would predict with them is they will come into Cumberland Sound for about 3 or 4 months. So we hope that they swim within range of our monitors and that we keep picking up detections of these animals. And then after a 3 or 4 month period, it should go very silent on these monitors, and we won't pick up any detections, because the Greenland sharks will then move out of Cumberland Sound, and as we understand, they then move up Baffin Strait to Greenland. The great thing is, with these acoustic tags that we put on, is they've got 10-year battery lives. So when we come back next year, we download the data, and then we redeploy these in the water. And we will do this for the next 5 years. So what we hope to then see is the same Greenland sharks will come into Cumberland Sound, stay for the 3 or 4 month period, leave, and then the next year come back again, so we can really identify what their migration pattern is and also what their residency time is in the Cumberland Sound area, and the same for the turbot as well.
Alors, est-ce qu'on peut prédire quel est ou quel sera l'impact donc de la prédation des requins sur les populations de saumon? So can we predict anything on the predation of sharks populations on the turbots?
What we can do is, with the satellite tags, which we have set at very high resolution settings every minute and a half, what we're looking at with those tags is, do these sharks spend a lot of time down at 1,200 meters when they're in Cumberland Sound? If they're spending a lot of time at 1,200 meters, we have a pretty good idea that they're feeding on these turbot, and they're staying in what we call these deep water pockets or holes where all the turbots are sitting. So this will give us a good indication of that. We already know from previous work where we dissected Greenland sharks and we looked in the stomachs that many of the Greenland sharks here in Cumberland Sound do have turbots inside them. So it is clearly an important part of their diet.
Et en conclusion, est-ce qu'on peut, on parle de science, est-ce qu'on peut lier la connaissance traditionnelle des Inuits aux aspects scientifiques, donc que vous êtes en train de mettre en place? So we're talking about traditional knowledge with the Inuit people. So can we make a link, any link between the traditional knowledge of those populations and the science?
Yes, we can, because from the traditional fishery, we do know there are peak periods when they have problems catching sharks, or the problem with bycatch of sharks in the winter fishery. So for example, I think in February time, the Inuits have now decided it's not a very good month to fish, because if they set their long lines in February, when they pull them up, every hook is a Greenland shark. So the Inuits have been sharing this information with us, which is helping us to guide our overall scientific research. Also key is where the Inuit are fishing. You know, all of our monitor positions in the winter fishing grounds are based on the actual locations of where the Inuit are going out and fishing through the ice. But obviously this is a changing dynamic as we have global climate change, and the ice cover is now changing in Cumberland Sound, and certainly if you speak to the Inuit over the past 5 years, this has been very obvious how this ice change, the amount of ice cover is changing. This is changing the dynamics of where these guys can fish as well. And what's actually happening is they can't go out to the original spots that they used to fish 15 or 20 years ago, and now they're having to fish much closer in towards Pangerton than they used to, because there just isn't the ice cover for them to be able to move out. So again, our monitors, we're putting them in positions where they're fishing at the moment, but we're also putting these monitors in places where they used to fish. So we're trying to understand this turbot movement over the historic fishing grounds to where they're fishing now as well.
Vraiment, en conclusion, est-ce qu'on peut dire que l'impact des changements climatiques, donc sur la couverture de glace, sur les pratiques donc de pêche des Inuits, est-ce qu'on peut dire que ça pourrait avoir un impact significatif donc sur les stocks et sur l'état des pêcheries dans un proche futur? So, you were talking about the climate change impacts on ice covers and of course on practices. But do you think it's an important future impact on the stocks and on the fisheries in general?
It's in terms of the fish themselves, we don't know yet. That's the big question. It's the big question obviously in science, you know, in marine science at the moment, is how global climate change will affect fish stocks. One of the reasons we think if the turbot do move between the summer fishing grounds and the winter fishing grounds is it's driven by temperature, a preference for a certain, quite a narrow temperature band. And this is why you have this movement. So obviously if we have global climate change where the ocean is warming, even just a slight warm by a couple of degrees in our ocean could seriously change traditional or natural movements, migrations of fish. So yes, it can have an impact on the actual fish species and where they occur, as well as impacting obviously where the traditional fisheries can operate just because of physical access to get to those sites.
Dr. Hussey, merci beaucoup pour cette entrevue. So Dr. Hussey, thank you very much for this interview.
Thank you
really
very
interesting. Thank you so much.
Nigel, could you just give us the spelling of your name?
Yeah, it's